your world one atom at a time.
This door, this tie, this keypad, and this guy are all things. And things are made of stuff. Tiny pieces of stuff.
Run!
No, I mean tiny, tiny pieces of stuff. Much tinier than you can see with the human eye. Now look around and count how many different things there are. Yeah, count everything. There's tires and tubas. There's kids and cows. There's wood and there's forests. There's fish in the sea. There's stars in the sky. There's even kitchen sinks. You can count thousands, millions, billions of things. We call all of this stuff matter. And it turns out that if we break matter down, take it completely apart, all of these things are made of just a few things. Imagine cutting a piece of cheese in half. Then, in half again. And in half again. And 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 again. 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 And again. And again. Eventually, you'd end up with a piece too small to cut. There'd be no knife sharp enough. Tiny, tiny pieces that couldn't be broken apart any farther. They'd be unbreak-apartable. We call them atoms. That's from a Greek word that means uncuttable. Atoms are too small to see, even with a regular microscope like this. Here is a model, a first look at an atom. Now, here are the main parts. Well, they're particles. Parts, particles, get it? Anyway, in the middle are very heavy particles, and buzzing around the middle are very light particles. Now, if we could see an atom, it couldn't look anything like this because atoms are mostly empty. Take a look at this. It's our proper proportion giant atom model of science. Now, this part isn't very giant. That's because it's just the nucleus, the middle of an atom. Now, in here are two kinds of particles, protons and neutrons. No one knows what they would really look like. The protons have a positive electrical charge, like a spark, and the neutrons have no charge. They're neutral. They just hang out in the nucleus. Now, buzzing around the outside of the nucleus are very small particles called electrons. Maybe you've heard of them. In fact, the flow of electrons from one atom to another is called electricity. If this vibrating, buzzing ball is the nucleus of an atom, how far away do you think the electron would be? Well, as far as you could jump? No. As far as you could throw a ball? As far as you could run? Well, yeah. Take a look. You can see it from here. It's way out there. the electron would be here. 500 meters, 5 soccer fields from the nucleus. So, everything that's made of atoms, everything that you can touch and feel, is mostly empty space. Empty space. Empty space. Empty space! Now, the electron weighs, a 10,000th of those particles in the middle. And it's going around so fast that it's only here now and then. It's here, and then here, and then I gotta go.
An atom consists of its nucleus and several rotating electrons that revolve around the nucleus.
If atoms are mostly empty space, how come when I jump on this crate, the atoms in my feet don't pass right through the atoms of the crate? Well, even though the electrons are really far apart, they repel each other so strongly, and they're whipping around the nuclei of atoms so fast that they make the atoms act like a solid. It's kind of the way this fan acts like a solid, even though the fan blades are really far apart. See? The paper won't go through. Atoms are mostly empty space! Oh, whoa!
So how small is an atom anyway?
This small?
Smaller.
This small?
Smaller.
How about this small?
Not even close.
Come on, it can't be any smaller than this.
Oh, it's way smaller than that.
No.
Yes! Atoms are so small that you could put 1 million on the pin of this head. I mean the head of this pin.
Who you calling a pinhead?
I'm not calling anyone a pinhead.
A is for atom. That's right. A is for atom, because atoms are the basic building blocks of all matter. Atoms are like the letters in the alphabet of the universe. So look what happens when we combine these letters. We get words. Atoms are like letters, and molecules are like words in our universal alphabet. All matter is made of atoms and molecules.
Hey, science guy.
Huh?
Even a banana cream pie?
Oh, yeah. Even a banana cream pie.
Atoms! Atoms are everywhere! I'm surrounded by atoms!
How do we know that atoms combine to make molecules? Well, please, consider the following. This is H2O. Water. 2 parts hydrogen and 1 part oxygen. When the atoms come together, they stick. Okay, but how do we know? Well, take a look at this. In here, we have some water. And we're passing electricity through it. When we do, we get 2 gases. If we let it go long enough, there'll be no liquid left at all, just the gases. And they're pure. They're each made of just 1 kind of element. On top of that, there's twice as much of this gas as this gas. By doing a lot of experiments like this, scientists have figured out that, H2O is 2 parts hydrogen and 1 part oxygen, with the hydrogens on one side and the oxygen on the other. Kind of like mouse ears. See? H2O is great. The ocean is made of H2O. You and I are full of H2O. It's wild. It's wonderful. It's water. You know, a feller could have seen that coming. Well, thank you for joining me on Consider the Following. See you real soon.
But here's a cool experiment you can do to see the spaces between molecules of water. First, take an empty pop bottle and fill it with exactly 1 cup of water. add another cup of water.
Hi, Mom.
Mark the 2-cup level with a marker. Now dump out the water.
Why do I have to do all the work around here? Here you go. You're welcome.
Now, add a cup of water to the bottle. Better. Get your parents to help you add 1 cup of 99% rubbing alcohol. The kind you get at the pharmacy.
See, 1 plus 1 doesn't always equal 2. There are a lot of spaces between the alcohol molecules, little pockets where the water molecules can fit. So when you mix a cup of water molecules with a cup of alcohol molecules, you don't get 2 cups of liquid. See?
It's a molecule thing. You can learn a lot about molecules just by mixing them together.
What makes one atom different from another?
The number of protons in the nucleus?
The number of protons in the nucleus. Take a look at this piece of metal. It's shiny, like silver. Now here's another piece of metal. It's shiny too, but it's a little bit orange colored, like gold. Well, you can tell they're both metals. You can look at them, rub your fingers on them, and bang on them.
Bill.
Now this material turns out to be aluminum, and this material turns out to be copper. Now the main difference between this material and this material is
The number of protons in the nucleus?
the number of protons in the nucleus. You can see and hear the differences.
Bill. Hey!
Now, scientists have grouped all the different materials, all the different elements that we can find into groups, which have come to be called periods. And we've arranged the periods on a table, the periodic table. So let's go to the chart.
The periodic table.
The table.
Yeah.
The periodic table.
Uh-huh.
Voila! The periodic table. See, every element has a name, and you know most of them. They're familiar. There's carbon, oxygen, aluminum, copper, iron. They're familiar. But there's some weird ones, too. There's like erbium, palladium, and krypton. Scientists have given each element a 1 or 2 letter symbol and a number. Now, that's not just any number. That's the atomic number.
The number of protons in the nucleus?
The number of protons in each nucleus. Now, there are 92 elements that occur naturally. And using these elements, we can make all kinds of interesting molecules. H2O, water. NaCl, salt. Now get a load of this one. C3H5N3O9, nitroglycerin, the highly explosive oily liquid used for making dynamite. It's all done with molecules.
Okay, what you got?
NaCl.
Salt. You?
H2O.
Water.
Beat this. C6H12O6.
Sugar. That is hard to beat.
Well, what you got?
What?
Only C10H14O.
Spearmint! You did it, cheat!
Just played the cards I was dealt.
Oh, yeah? What's this?
My name is Warren Buck, and I'm a nuclear physicist, and I study inside of atoms, inside that mound. We're about 100 feet underneath the top of that mound outside, and we're inside the experimental hall where we study the inside of atoms. And to study those atoms, we need a giant machine. This giant machine is like an electronic eyeball, and it sees inside of the atom. Inside the nucleus, inside of a proton, inside of a neutron, we have quarks. This room is for kicking the electrons to higher and higher energies so that we can shine them, direct them onto atoms to find out the motion of those atoms. By the time the beam arrives here, it's traveling almost at the speed of light. Once the electron beam gets enough energy from the accelerator, it's delivered here to the target. This is where all the action is. These atoms are struck by the electron beam and broken into smaller pieces. Those smaller pieces are what we study. All the information from those big machines in the experimental hall are being channeled to this room. And that information teaches us a variety of new things about the nucleus of an atom. And beyond that, what quarks are made of, it's a very, very interesting question. I love looking deeper and deeper and deeper into matter, seeking the fundamental building blocks of the universe.
Bill? What's the matter, Bill?
Everything. Everything matter. Except energy, of course. That's right. Everything in the universe is either energy or matter. Matter or energy. Energy or matter. Matter or energy. Energy or what? Or matter. Or matter. 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 See, like heat, light, and sound, that's energy. This torch is made of atoms and molecules, that's matter. Everything that's a thing is matter, like this hot dog. The hot dog is matter, but the heat that cooks it is energy. So, really nothing's a matter. Except, I'm gonna have to have some mustard.
Let's get some mustard over here.
And a bun.
Get him a bun, too.
Ah, look. Nothing's a matter. Energy and matter. What a great combination.
That's very nice.
See this amusement ride made of toy parts? It's like a molecule, and each part is like an atom. Atoms are the smallest pieces of stuff that's still stuff.
Tiny, tiny pieces of stuff. Atoms.
Atoms are the building blocks of all
matter.
All matter.
All matter is made of atoms and molecules. Even a big cream pie.
Atoms! Atoms are everywhere!
This is a model of a carbon atom. And you say, what's the big deal? What's the big deal? It's carbon, okay? Carbon is everywhere. Carbon is in every living thing. The trees, carbon's in the trees, carbon's in the grass, carbon is in you and me. Carbon's in the cows, carbon's in that bowl over there. Carbon is in the horses. Carbon is all over the place. Carbon's even in the air. Carbon is what makes life go. Carbon makes the chemicals of living things. And carbon is so important. Are you listening to me? We've named a whole branch of chemistry after carbon. Organic chemistry. Organism, organic. Are you with me? Organism, organic. Okay? It's vital. It's important. That's why, don't say what's the big deal about carbon. Carbon is the key to life. You have got to respect that.
popsicle combination. Atomic combination matters cool, it's made with molecules. And did you ever think about the molecules? The bond is very cool, very, very cool. The stars and planets are made of an atom combination. And those atoms are so tiny that you never see them, like hydrogen and carbon and oxygen. We know that they exist because we see how they react. And there's only 92 of them, you know that atoms all combine. They make up molecules. Matter is all around. Atoms, atoms.
Well, that's our show. Thanks for watching. If you'll excuse me, I've got some atoms and molecules to dissociate and recombine. See ya!
Produced in association with the National Science Foundation.
Where are you guys going? There's atoms and molecules there. This is fabulous. You and I are made of atoms and molecules. Atoms and molecules, I mean, suit yourself. If you don't want to hang out, you know, and enjoy some lovely molecules, that's fine. You go ahead. You just go nuts. Knock yourself out. Because I'll see you guys down the road. Don't kid yourself. The road's made of molecules. Oh, yeah, so is that vehicle, everything. You and I are molecules. The television's molecules. The sun is bringing the energy down here. That's molecules. Yeah, sure it is. Kid yourself. You kidding me? Look at all this stuff. Those mountains, they're